to molecular formulas, which we'll talk about in the next program. An empirical formula is a formula where we have written the subscripts in the lowest whole number ratios. And what I mean by subscript and lowest whole number ratios are the numbers that are in the bottom right-hand corner of the element symbol when you're writing a compound. So let's take our pens and let's get an example. I'm going to draw it in, let's do blue so you can see the difference. Let's say we have H2O. I want you to be fully aware that these numbers in the bottom right-hand corner, this 2 and this invisible number that you can't see, are called subscripts. And the subscripts that are here, this is a 2, this is a 1. The 1 is invisible. We don't generally write 1s in when we are talking about subscripts because they're understood that they're there. When we look at those subscripts, the subscripts are in a 2 to 1 ratio. And they are in the lowest whole number ratio that we can get. We cannot reduce the 2 to the 1 any further. When they're in the lowest whole number ratio, we can say that we have an empirical formula. Now, you're going to be asked on a Regents exam to figure out which of the following is an empirical formula. Or they're going to give you a compound and say, what is the empirical formula for this compound? If you're trying to identify an empirical formula, the first thing you're looking at is these subscripts. Are they in the lowest whole number ratios? If they are in the lowest whole number ratio, then it is an empirical formula. So you can think of things like sodium chloride, you can get AlPO4, okay? Any of these things are an empirical formula because you've got a ratio here of 1 to 1, and you've got a ratio here of 1 to 1 to 4. Okay? You cannot reduce these subscripts any further. Whenever you have an ionic compound, ionic compounds, also known as salts, they must be written empirically. And that's why when we did the crisscross, back when we were writing formulas, we said crisscross, applesauce, drop the charges, and then simplify. We had to make sure that our subscripts were in the lowest whole numbers. Let's do one. Let's take magnesium and sulfate. Okay? And when we did the crisscross, let me get a different colored pen so we can write the oxidation numbers in. We're going to take magnesium's oxidation number and we're going to put a +2 there. Now where did I get that from? If you look at your periodic table, let's pull it up here. You look at your periodic table, let's see, magnesium is right here. Do you see how there's a +2 right there? That's where that came from. And then we're going to look at the sulfate ion. Now the sulfate ion, let's bring this back. The sulfate ion we got from our reference tables. And the sulfate ion is going to be on your polyatomic ion chart, which is all the way at the top here. Table E, let's find table E. And you see that you have SO4 minus 2. That minus 2 is your number that you're going to use for the crisscross method. So let's bring back our page and our notes. And we're going to put a -2 on this sulfate. And we're going to cross them down. Okay, so that -2 comes down here as a 2. Drop the charges. This 2 comes down here as a 2. And this goes in parentheses. So you've got something that looks like Mg2SO42. Well, we have an ionic compound here. We have a metal, which is magnesium, and we have a polyatomic ion, a non-metallic polyatomic ion. And we're going to want to keep these in the lowest whole number ratios. So the last step in the crisscross method was to simplify. So we've got Mg, 2 is to 2 as 1 is to 1, but I'm not going to write the 1 in because 1s are understood. And SO4 And then that could be in parentheses with a 1 outside, but we don't need to write the 1, so it's just MgSO4 for magnesium sulfate. And now we have this ionic compound written empirically. It's empirical because I cannot reduce these subscripts any further. 1, 1, 4. Just like we had here. 1, 1, 4. Or 1 to 1. Okay? Let's move on now to our next video.